In this video, I'm going to be talking about Newton's third law, what it is, and how it applies to a bunch of different scenarios. It's that every force has an equal and opposite force, and that all forces come in pairs. It's oftentimes said that Newton's third law is every action has an equal and opposite reaction, and I don't particularly like that definition because it sounds like the force is being applied and then another force is reacting to it and pushing or pulling shortly after, when in fact the force pairs are happening simultaneously. So let's get into our first example over here, where a truck is crashing into the car, and as the truck is crashing into the car, it applies a large force onto the car towards the left, and then at that same moment, the car is pushing back on the truck to the right, and these forces are equal in magnitude and their amount of force and opposite in their direction. Now, if you take a look at these two vehicles after the crash, you might be thinking, didn't the car get more damage because there's a really large dent in the side? And didn't the truck get less damage because there's only a little scratch on the front? Well, the results can make the amount of force seem to be different, although they are not. And the reason why the results are significantly different is because you're talking about two objects that are significantly different in their mass and their construction. So you can't compare the results of what happens to both of them and then say one gets more or less force when in fact every force always has an equal and opposite force. Going to our second example over here, basically the reason how anything moves is it's depending on something else. So as you push or pull and you get that equal and opposite force, that's the thing that's actually propelling you forward. For example, when you're walking or running forward, your feet are pushing back, and that equal and opposite force that you get from the ground is the one that actually propels you forward. Same thing with swimming. As you push the water back, the water pushes you forward. Okay, in this case over here, this is a classic case of Newton's third law where a space shuttle is taking off into space, and it would seem like it's actually pushing off of the ground, which it's actually not. What's happening is that these rockets are ejecting a large amount of gas downwards, and as the rocket pushes a lot of gas downwards, the gas pushes the entire space shuttle upwards. Now you might be wondering, how can you push out gas and lift an entire space shuttle and these rockets up into space? Well, the reason being is because there's lots of propellant, lots of gas being shot downwards, to the point where there's maybe 20,000 pounds of propellant being released per second in order to push this space shuttle upwards. So in a lot of these cases, what you can do is you basically write out what's happening with one of the forces and you switch the nouns and the direction. So let me show you an example before I explain in more detail. So if you're analyzing any force, like I was saying, you can switch the nouns and the direction. So what I mean by that is the initial force that you might be paying attention to is how the rocket pushes the gas down. Now, if you switch these two nouns, the rocket and the gas, and then the direction of it, then it's the gas pushes the rocket up. That's the equal and opposite force. So in all these cases, you can apply that same sort of strategy where the hand pushes the water back and the water pushes the hand forward, and then the foot pushes the ground backwards, and then the ground pushes the person forwards, and then so on. The last scenario that I want to bring up is a person doing an ollie on a skateboard, and ollie is basically just doing a jump on a skateboard. Now, if you jump straight up on a skateboard, you're not really going to make the skateboard rise off of the ground. Your feet are just going to rise up away from the skateboard. So what's actually happening is an example of Newton's third law. What you would do is you would apply force on the back part of the skateboard, And as you apply force on the back part of the skateboard, it pushes down into the ground, and then the ground is going to have a normal force that is equal in the opposite direction. And that normal force pushes on the board and then makes the board rise up off the ground. So basically, what it is, it's a controlled collision between the skateboard and the ground that allows the skateboard to rise up off the ground. And then, in addition, the friction between the person's feet and the skateboard could help pull the skateboard up a little bit more. And then you can jump off the ground in that case. So, in all these different scenarios, like I said, every single force has an equal and opposite force, and all forces come in pairs. And if you use this strategy right here, like I said, what you can do is basically switch the order of the nouns and switch the direction, and that will be able to identify the other force that's present. I hope that was helpful in helping you understand Newton's third law. Thank you for watching and listening.